So again, we've got a 0 by 0 form, and I was differentiating. So let us differentiate and see what we get. Limit x tends to 0. Now ddx 2x e to the power of x. This is twice ddx x e to the power of x plus ddx sin x. I'm doing one step extra because I have to use a u into v rule here. And ddx 2x is 2. Okay. Limit x tends to 0. Now we'll use u into v rule. X ddx e to the power of x plus e to the power of x ddx x, and ddx of sin x is cos x. All this divided by 2, which is equal to limit x tends to 0 twice. Now x, what is ddx e to the power of x? It is e to the power of x. So you get x e to the power of x, and ddx x is 1. You simply get e to the power of x plus cos x divided by 2. Now let's check whether this is a determinate form or not. So you have twice x e to the power of x plus e to the power of x plus cos x divided by 2, putting x is equal to 0. So you get twice 0 into e to the power of 0 plus e to the power of 0 plus cos 0 whole divided by 2, which is twice 0 into e to the power of 0 is 0, e to the power of 0 is 1, cos 0 is 1, divided by 2. Yes, now you are getting a determinate form. So you put the values. This is twice 0 into e to the power of 0 plus e to the power of 0 plus cos 0. So you get twice 0 plus 1 plus 1 divided by 2, which is 2 plus 1 divided by 2, 3 by 2. Yeah.
Yes, sir.
So
Yes, sir.
let me do one more, then I'll finish.
Okay, sir.
Because this exercise, two more sums will be left. So I'll finish this exercise tomorrow. Okay, so just one more sum.
Okay, sir.
Um, this one, limit x tends to 0. So given limit x cos x minus log 1 plus x divided by x square. Okay. Okay. Now, do you remember that limit log 1 plus x divided by x?
Sir, we have not written limit x
Huh?
tends to 0.
Yes, yes.
We have not written limit x tends to 0.
Oh, yes, the limit x tends to 0. What was that limit? Um, 1 by x log 1 plus x. Oh, but then that is not that form. Fine. So, what we'll do here, we'll first check what form this is. Putting x is equal to 0. You get 0 cos 0 minus log 1 plus 0 divided by 0 square. So, you get 0 minus log 1. by 0. And what is log 1? Log 1 is 0. We're getting a 0 by 0 form. So this is a 0 by 0 form. So we'll apply L'Hospital's rule. X cos x minus log 1 plus x divided by dx x square. Limit x tends to 0. Okay, now ddx of one more step I'll do, because I will have to use a u into v rule. Minus ddx log 1 plus x whole divided by ddx x square is 2x. Use u into v rule. X ddx cos x plus cos x dx x minus ddx log 1 plus x is, first differentiate the log to get 1 by 1 plus x, and ddx of 1 plus x you know is 1, so into 1 is will give you the same, whole divided by 2x. So this is limit x tends to 0, x into ddx of cos is minus sine, plus cos x into 1 is cos x, minus 1 by 1 plus x, okay, whole divided by 2x. Okay, so now
Okay.
we'll again check whether this is determinate form or an indeterminate form. Okay, so let's check. You have got x into minus sine x plus cos x minus 1 by 1 plus x divided by 2x. This is obviously an indeterminate form. Once again we have got, okay, because in the denominator I'm getting a 0. So 0 into minus sine 0 plus cos 0 minus 1 by 1 plus 0 divided by 2 into 0. So in the numerator what are you going to get? You're going to get a 0. Cos 0 is 1 divided by 0, which is nothing but a 0 by 0. So this is clearly again a 0 by 0 form. Okay, so but before differentiating we simplify a little bit. Before applying L'Hospital's rule, just simplify this a little bit. Limit x tends to 0, you get minus x sine x plus cos x minus 1 by 1 plus x divided by 2x. Now again use L'Hospital's rule. ddx of minus x sine x plus cos x minus 1 by 1 plus x whole divided by ddx of 2x. This is L'Hospital's rule. Okay, now we'll check again. We'll first differentiate and then check again. ddx or minus ddx of x sine x plus ddx cos x minus ddx 1 by 1 plus x whole divided by ddx 2x you know is 2. So limit x tends to 0. Now differentiate by u into v rule. So you minus here x ddx of sin x plus sin x ddx of x plus ddx cos x is minus sin x. Let me straight away write, because in the next step again I will have to simply write minus sin x. ddx cos x is minus sin x, and ddx of 1 by 1 plus x will be, first you will differentiate it, first you will differentiate 1 by x, okay, into ddx of 1 plus x. So this is minus of minus 1 by 1 plus x square become plus 1 by 1 plus x square. No problem with this differentiation.
No, sir.
And you close the curly brackets here. So divided by 2. So this is limit x tends to 0 minus x cos x plus sin x minus sin x. I think sin x will cancel by 1 by 1 plus x whole square whole divided by 2. So this is limit x tends to 0 minus x cos x minus sin x. Oh, it will not cancel. Minus sin x 1 plus whole square by 2. Just simplify a little bit, then we'll check with by putting x is equal to 0. Minus x cos x minus 2 sin x minus 1 by x whole square whole divided by 2. Now let's check here what we are getting. So you have minus x cos x minus 2 sin x minus 1 by 1 plus x whole square whole divided by 2. Putting x is equal to 0. You get minus 0 cos 0 minus 2 sin 0 minus 1 by 1 plus 0 square whole divided by 2. Okay, so what do you get? 0 minus 0 minus 1 by 2. You get minus half. So this is a determinate form. So now you can put the value. No longer application of L'Hospital's rule. Minus 0 cos 0 minus 2 sin 0 minus 1 by 1 plus 0 square divided by 2, which is 0 minus 0 minus 1 by 2, which is minus half.